In this video, we'll be learning how to find unknown side lengths in right-angled triangles. So, let's get started and come up with an example. Let's say we're given the following right-angled triangle. With an interior angle of 30 degrees, a hypotenuse of length 10, and let's say we are asked to find the unknown side length, which I'll mark in purple here, x. So how would we do this? Well, the idea here is, because this is a right-angled triangle and we have one side length and one angle, we're going to be using the trigonometric ratios. Now remember, those are sine, cosine, and tangent. And we saw in the previous video that we could use son-cah-toa to memorize the different trigonometric ratios. So our starting point really is the following. We need to highlight the fact that we're given this angle 30. And relative to that angle 30, we are looking for the opposite side x, and we are given the hypotenuse of the right angle triangle. So if we just quickly write that, we have the angle, we're looking for x, which is the opposite, so O, and we have 10, which is the hypotenuse. We have h. Now, the trick is, looking at son-cah-toa, which I wrote here, which of those three, so, ka, or toa, do you see which has both O and H inside it? Well, it shouldn't take you too long to see that the only one that has both O and H is so. Indeed, I can see that I have O and H here. What this tells us is that we're going to be using so, in other words, remember, so means that the sine of some angle A is equal to O divided by H, which was opposite divided by hypotenuse. And the S on sine, of course, is the same as the S in so. And this so allows us to choose the right trigonometric ratio to use. So let's see. In this right angle triangle, remember we said that x was O and h was 10. So we can actually write sine of the angle, which in this case is 30, is equal to opposite, which is x, over hypotenuse, which is 10. If we multiply both sides of this equation by 10, and the reason why I'm doing this is because 10 is on the denominator here and I want to get rid of it. If we multiply both sides of this by 10, this leads us to 10 times sine of 30 is equal to x, which we can write the other way around just to make sure that from left to right we read x equals to 10 times sine of 30. And now with your calculator, you can calculate 10 times sine of 30. And you should find x is equal to 5. And we're done. We've just used a trigonometric ratio, namely sine, to find an unknown side length in a triangle. And if we wish to, we can complete our diagram and label the unknown side length. We had this right angle triangle, the interior angle was 30, the hypotenuse was 10, and we have just found that the unknown side length x is equal to 5. Let's look at another example. Let's say we're given the following right angle triangle. The interior angle is 40. We have a side length equal to 8 and a side length p. And we're asked to find the unknown side length p. Well, again, the approach is similar. We have to think of the angle 40 and ask ourselves, relative to 40 degrees, what are we looking for and what do we have? So relative to 40 degrees, we are looking for the opposite side length, P, and we are given the adjacent side length, 8. Now again, look back at your trigonometric ratios, son-cah-toa, and ask yourself, which one of these ratios has both the opposite and the adjacent? Remember, opposite would be O, and adjacent would be A. Now, once again, it doesn't take us too long before we manage to pinpoint toa. This is the only trigonometric ratio which has both O and A inside it. And so this tells us that the tangent of the angle that we have, which is 40, is equal to the opposite side length divided by its adjacent side length. And the opposite side length is exactly what we're looking for. Tan 40. The opposite side length is P, and we are given the adjacent side length 8. Now once again, I'm going to multiply here. I'll multiply both sides by 8 to get rid of this 8 on the denominator, which will lead us to 8 times tan of 40 is equal to P. And I'll rewrite that the other way around, just to make sure that the unknown is on the left-hand side, simply because it looks better. P is equal to 8 times tan of 40. And using our calculator and rounding to 2 decimal places, we find P is equal to 6.71. And there we go. We just solved another problem. And we can complete our diagram, just as we did in the first example, and add the unknown side length. Remember, we had the right angle triangle, which looked something like this, a 40-degree interior angle, the adjacent side length was 8, and we have just found the opposite side length, P, is equal to 6.71, and that is, of course, rounded to 1 decimal place. Let's look at one more example. Let's say we're given this right angle triangle. We're given this interior angle 60 degrees and this side length 8, and we are looking for this side length Q. So again, we go through the whole process of looking at what we have relative to the angle that we are given. So relative to that 60-degree angle, we are given 8, which is adjacent to 60 degrees. So we can already write we have 8, and that is adjacent. So I write capital A. And we are looking for Q, which is opposite the right angle, and is therefore the hypotenuse of this right angle triangle. So I'm going to write Q, which is the hypotenuse, so capital H. And now once again, I go through the process of writing son-cah-toa, and looking at this, I'm looking for the only one of these 3 which has an A and an H inside it. And we can see quite quickly that the only one is Ka. What this tells us is that we have to use cosine. And it tells us that cosine of the angle that we have, so in this case 60, cosine of 60 is equal to the adjacent divided by the hypotenuse. And just as we pointed out and wrote down up here, the adjacent is equal to 8, and the hypotenuse is equal to Q, which is what we're looking for. So we're going to write that. Cosine of 60 is equal to 8 divided by Q. Now in this case, the unknown that we're looking for is on the denominator. We can see it here. And this will add one more step to our algebra, but don't worry, do not panic, nothing too tricky. we'll start by multiplying both sides of this equation by q. And if we do that, we'll end up with q times cosine of 60 is equal to 8. And now, since what we're looking for is q here, and it's being multiplied by cosine of 60, we're going to divide both sides of this equation by cosine of 60 to get rid of the cosine on the left-hand side. So dividing both sides by cosine of 60 leads us to q is equal to 8 divided by cosine of 60. And once again, if we plug that in our calculators, we find q is equal to 16. And we're done. And as always, it's good practice to complete the diagram that we had by adding the side length that we found. So we had this right angle, the interior angle was 60, we were given this side length q, and we have just found the length of the hypotenuse, q is equal to 16. And there we go. That's how we calculate side lengths using the trigonometric ratios.